Hello, everybody. So today we are going to be discussing 4.2, which is solving inequalities using addition or subtraction. So right now, I would like you to make sure that you have your math composition notebook out, you have a writing utensil, and make sure that as you're going through and watching this video that you're writing down everything that is on my screen. So you have it in your notes. All right, let's get started. So our learning target for today, I'd like you to write this over here, is I will be able to solve inequalities using addition or subtraction. All right. So that is our learning target for today. Now we're going to be solving inequalities using addition or subtraction. Notice that last chapter, rather than solving inequalities, we solved equations. So let's just kind of remember what we did to solve equations using addition or subtraction. Well, the most important thing to note is that, remember from chapter 3, addition and subtraction are inverse operations. So this is important to note. So in case you forgot from chapter 3, addition and subtraction are inverse operations. So we're going to get started. This is going to look very similar to chapter 3 with just a little spin to it because it's an inequality. So most of this will probably be a review for you. So let's go ahead and look at example 1. Solving an inequality using addition. So first thing we're going to do, you can still draw the line down the middle, okay? Again, you want to do all the same steps from chapter 3. Look at the side with the variable on it. So that's the left side. Then you want to look what's attached. Well, I see a -5. How am I going to cancel out a -5? Well, hopefully you're thinking I need to add 5. And remember our algebra rules. Whatever you do to one side, you have to do to the other. So we're going to add 5 on both sides. Then we're going to be left with x. Make sure you write the inequality symbol, okay? You're not writing an equal sign. You're writing exactly this inequality symbol. So it's going to be x is less than -3 plus 5. That's going to give me a +2. So this is the answer to my inequality. It's x is less than 2. Okay. Now notice over here, it says graph the solution. So this is something we didn't have to do in chapter 3. So this is pretty much going to be the new thing that we're learning. So you're going to draw a number line. All right. And you're going to want to make sure that I'm going to put my 0 here. 1, 2, 3, 4, 5, -1, -2, -3, -4, and -5. Okay, so remember that you want to put the point wherever that number is. So it says a +2, okay? So we're going to plot our point on +2. And now we need to decide, do we need to fill in our circle or leave it open? So think back to 4.1 and actually go back into your notes and look. Do we need to leave the circle open or should we fill it in? And how do we know that? So think about that. Go back to your 4.1 notes and let me know. Okay, so I hope from your notes you notice that there is no line underneath this inequality symbol. Therefore, you need to leave this circle open. Okay, so it is an open circle since, and the way we think about this is 2 is not a solution. Okay, and what that means is x has to be less than 2. Okay, it's not x has to be less than or equal to 2. Okay, there's no equal in it. It's just it has to be less than, which means 2 is not a solution. Okay, so we have our point down. Okay, we know it's an open circle because there's not that line underneath it. We know it's not equal to. So now the next point is we need to test points. Okay, so your first step is going to be to test a number to the left and the right of 2, okay? So let's go here. So let's pretend if x equals 0, okay? So over here, if x equals 0, then, and then you just literally fill in that number where the x is. So it would be 0 is less than 2. Is 0 less than 2? Yes, I would agree. Okay, so we know that's right. So let's just check a number on the right just in case. So look for a number on the right of 2. And I'm going to pick 4. If x equals 4, then fill in that 4 into that original equation up here. So 4 is less than 2. Is 4 less than 2? No. So do we need to shade to the left or to the right? Well, this is the left, this is the right. Which one worked? The left side worked. So we need to therefore shade to the left of 2. So I'm going to shade to the left of 2. Okay, my shading is going to be to the left. All right, and that is our solution. We have x is less than 2 boxed in. Then I also have my clear graph shown like this. So this is the type of work I will expect to see on all of the big ideas problems for 4.2. So make sure you have this down in your notebook and you're ready to show work exactly like this on your big ideas assignment. Okay, let's go to example 2. So solving an inequality using subtraction. So same thing as chapter 3. We are going to draw a line down the middle, and we want to pay attention to the side with the variable on it. Well, it looks like the variable's on the right side. Then I want to see what's attached to the variable. Well, I see a plus 14, all right? A plus 14. So in order to cancel out a positive 14, we need to do the inverse operation, which is subtraction. So I'm going to subtract 14 from both sides because remember, whatever you do to one side, you got to do to the other side. So these are going to cancel. I'm going to be left with x. Don't forget to write the inequality sign, not just an equal sign. That's a common mistake people do. So I'm going to write is greater than or equal to 13 minus 14. That's going to give me a negative 1. So that is my answer. Negative 1 is less than or equal to x. All right. So some people get a little bit turned around when the x is on the right side of an inequality, okay? So we want to practice reading these. So right now, say with me. Negative 1 is, notice, the little alligator mouth, the closed mouth, is towards the negative 1. So it would be negative 1 is less than or equal to, because the line's underneath, x. If we want to read it from right to left, we would read it as x is greater than, because the big alligator mouth is facing the x. So x is greater than or equal to negative 1. Okay, and that's how we'd say it, reading it that way. So you can also rewrite it if it makes more sense. So it says negative 1 is less than or equal to x. You could rewrite it as just literally swap them around, okay? This reads the same thing. It just reads from left to right, which might be a little bit easier for you. All right, so still, they're the same exact answers. I just shifted the variable on the sides, and I made sure that the alligator mouth, the inequality, was facing the correct way, okay? So that's something you can do. All right, so now we're going to want to draw our graph, okay? So here's our graph. I'm going to write 0, 1, 2, 3, negative 1, negative 2, negative 3. All right, and remember, you want to plot your point at this number right here that we solved for. So I'm going to draw my circle at negative 1, okay? Now we need to decide, should we fill it in or leave it open? So I would like you to look back at 4.1 and decide. This is the inequality symbol, greater than or equal to. Do we need to fill in the circle or do we need to leave it open? Okay, I hope that you all said we should fill it in, okay? And the reason we should fill it in is because, so fill in circle, since negative 1 is a solution, okay? And what that means is negative 1 is part of the solution set because it says x has to be greater than or equal to negative 1. Notice that line underneath means or equal. So negative 1 could actually be a solution. Therefore, we fill in the circle. Okay? Now we're going to go and do what we always do, which is we need to test a number to the left and the right of negative 1. Okay? So let's do it down here. So if x equals, let's pick a number to the left. Let's pick negative 3. So if x equals negative 3, then we plug in negative 3 for the x. -3 is greater than or equal to -1. Okay, think about this. Is -3, so a bigger negative number, greater than or equal to -1? Is that greater than? No, that's less than, okay? That's also to the left of it. So that's less than, okay? So that's a no-go. And that's to the left. So now let's pick a number to the right. If x equals, let's pick +2. If x equals +2, then fill it in. +2 is greater than or equal to -1. Is 2 greater than -1? Yes. Okay, so that means that everything to the right is a solution. All right. So therefore, we want to shade to the right of -1, the point, because we tested the point. Also, think about it logically. X is our solution set, okay? So if X has to be greater than or equal to -1, where are my greater numbers? To the right or to the left? I hope you're thinking to the right, okay? So therefore, that is where we shade. The testing the point is just to make absolutely sure that our inequality stays true when we plug in those solutions. And just a little note, you could plug in any number to the right of -1 and it would work, okay? 0 is greater than or equal to -1. That works. 1 is greater than or equal to -1. That works. You could plug in any number. It goes literally to infinity. So that's why in 4.1, when I said inequalities have a solution set, not just one solution, that's what the shading represents, okay? And that's because you could plug in multiple numbers and it would still work. It would still stand true. So let's just remind ourselves it's a solution set, not just one solution when we're working with inequalities, all right? And that's what our shading represents. All right, so that is 4.2. Hopefully most of it is just review from chapter 3 besides the graphing. Make sure you have these down in your notes so that you can use these on your big ideas homework. And if you have questions, let me know. Thank you for watching.